All right, we're back here to do a couple more examples from section 7.4, and we've kind of zoomed forward to some of the questions that are starting to ask us about hypothesis test. So, if your null and alternate hypotheses are the null hypothesis, the row is equal to 0, the alternate hypothesis, the row is greater than 0, then the test is, and we have here whether we're left-tailed, right-tailed, or two-tailed are the real options. In this case, we just have left or right. This arrow is pointing towards the right, so that means it's going to be a right-tailed test. If we reject the null hypothesis, remember the null hypothesis is that there is no relationship, that would suggest the data has a significant, and in this case, since we're doing a right-tailed test, it's going to be an increasing trend. If it's a left-tailed test, it's a decreasing trend. And if we're just testing to see if there is a relationship, then we would say a relationship if it happened to be two-tailed. So this is kind of, again, what we have here. You have some options. There's a couple of these that are repeated, but I'm going to get to one where we're kind of doing the whole test here. It says you wish to determine if there is a negative linear correlation between the two variables at a significance level of alpha equals 0.001. You have the following bivariate data set, and that just means we have pairs of data. What is the correlation coefficient? Accurate to 3 decimal places. What's the p-value? And then our conclusion. So, asking us for certain parts of our hypothesis test. So, I'm going to grab this data set and go to Excel to start doing work, which I think we have here. So, again, you should be pasting special. If you don't, you might run into some trouble. And it's kind of okay. Anyway, so at the top here we have alpha equals 0.001. And then I also need to find how many pairs of data I have. And so I'll just grab the X column, maybe. Phantom action. Okay. We've got 23. You can also use the count function if you like, and you're looking for how many pairs there are. So I have the formula here for our test statistic. Since we're asked here for a negative linear correlation, remember our null hypothesis is that I'm going to just say P is 0, even though it's really rho. And P maybe I shouldn't do here, so maybe I should use rho. I think that's how you spell it. I'm not sure. So then our alternate here, that's H sub 1, would be that rho is less than 0. And so that means we have a left-tailed test. And again, this part comes from here, a negative linear correlation. So that's what we're testing. And really that means our test statistic, well, let's see. We're going to be looking for wherever it is. We don't know where our test statistic is, but in my picture, say it's over here, I'm looking for the area to the left. So in a lot of the previous ones we did this two-tailed. So R is going to be using the correlation function, correl, and grab the first data set and the second. So we have a negative correlation coefficient, which at least lets us know that our data is moving down. So I'm putting a T here, but this is really our test statistic. And it is a t-test because this is our formula here, so it kind of makes sense. So it's R times the square root of n minus 2, and then we divide that by the square root of 1 minus R. I don't know why it does this sometimes, and it won't let me grab the box there. So what is that, G4? And that quantity gets squared. And so remember it's R here and then R there. So grab the right one, be a little creative. And we have a negative test statistic. So my picture is a little bit off, and the negative 6 would be probably way over here. So I'm looking to find the p-value. And since this is a left-tailed test, I can just use, well, I need to use the equal sign, t.dist, and I use the test statistic. The degrees of freedom is n minus 2, and then true, and we get this little value here. Remember, this means 1.6636 times 10 to the negative sixth. So that's 0. I've got 5 zeros and then a 1 6. So in answering these questions here, first of all, the correlation coefficient, negative 0.80, and then that 6 is followed by another 6, so it will round up. The p-value, the 4 decimal places, I've got bunches of zeros. And so our p-value is less than our alpha, so we reject the null hypothesis, which means there is sufficient sample evidence to claim that there is a statistically significant negative correlation. Now, a lot of these before we had is and is not, and notice there's a slight switch to is insufficient, so that is there is not, so just be really careful. I accidentally clicked the wrong one earlier. So this, and there we go. And really, these are the types of questions that we have. We just get kind of another one here, maybe a bigger data set, answering the same questions. So you have more than enough tools now. Good luck, and let me know if you have any questions. Thanks for watching.